Welcome to this GHS tutorial on intact stability. Tutorial number 510 covers stability limits. So today we're going to really focus on the limit command in GHS and how to apply limit titles. Now, the limit command is a very big command in GHS, and it's central to evaluating stability rules and regulations. There are several different implementations of the limit command, and we're going to be covering angle limits, area ratio limits, writing arm limits, and GM limits. So these are the major things that will be necessary to cover most of the stability regulations you will see. But first, a disclaimer. This presentation is for instruction only. It is not to be used in engineering for construction, and I'm not a representative of Creative Systems. This is all unofficial training based upon my own personal experience. If you are interested in the official training, you can contact Creative Systems. The information is listed at the bottom of this screen. I highly recommend that you use the official training and investigate it. It's very detailed and very much worth it. So let's talk about stability limits. Well, first off, what is a limit command? Or what are stability limits? And these are basically any formula for stability requirements. So it can be something as simple as saying that the GM must be greater than 0.5 meters. That's a stability limit. And there can be far more extensive stability limits as well. And you'll find that various regulatory bodies have created various forms of stability limits meant to test different items. And so GHS over the years, or Creative Systems over the years, have added to the stability limit command to give it all the intelligence to actually programmatically describe all of these different requirements. Now, it's very important to know that the limit command, which is what we're going to be talking about today, it does not actually evaluate stability. The limit command only defines the criteria that your vessel will be evaluated against. So what we're going to do today is not how to actually do a full stability analysis. This is just the first step of a stability analysis, which is defining the criteria. Now, this is one that it's definitely worth reading the help file on. If you type help limit, that's spelled it wrong. You type help L-I-M-I-T. So you can see I made a slight typo there. But type that and you'll find a very extensive help file on the limit command, and that's one that's definitely worth reading. Okay, so the basic limit command, how does it work? Okay, we start with the limit command, that's the keyword, L-I-M-I-T, a number, and then you have to break this down to, well, in the general sense, this is how the limit breaks down. So you've got the number, the type of thing that you're measuring, and then a whole combination of angles and keywords, greater than or less than, and then your actual value. So you can see the limit number is just 1, 2, 3, going up in increasing order. So you'll actually define what are called criteria sets that are multiple groups of limits together at once, and GHS will evaluate all the limits. And so you'll actually have limit 1, limit 2, limit 3. That's just the different sequence, or the different limits you've defined. And then the stability criteria, that's the thing you're actually trying to measure. Is it the angle of heel? Is it the area under the GZ curve? Is it the GZ value itself? The thing that you're trying to measure. And that's got specific keywords to pick which thing. Angles and keywords, this is what we're going to spend most of the presentation about, is these different angles and keywords and how to specify them all. And then this can either be a greater than or less than your value specified. So big N pointing to the left, that means greater than, and big N pointing to the right, that means less than. And then the value is going to be an actual number. So this has to be a specific number that you're going to test against. Now, just look a little bit more at the formatting. This angles and keywords thing, it's not actually one parameter. That actually breaks down into, we have a value, angle, or I'm sorry, the C1, C2, and C3, these are keyword designations again. And so you can actually specify up to three angles that can be included in. And we'll explain more in some examples about why you might actually need to specify three separate angles. But first, let's talk about the different limit types. So these are the keywords that I was telling you about for the different things that you're going to measure against. So we have angle, those are the healing angle limits. Area, that's going to be the area under the writing curve. Ratio, that's going to be the writing area ratio. So that's the ratio of area under the writing arm curve to area under the healing moment curve. We've got writing arm limits, so that's the actual GZ value as it varies with heel angle. RAR is writing arm ratios. And that's slightly different from ratio itself. Or excuse me, RAR. So yeah, the difference between ratio and RAR is this is ratios of areas under the GZ curve. And this is the ratio of actual writing arms. So that's going to be the writing arm compared to the healing arm. GM upright, that's the actual GM value. And then flood height is the height of different flooding points. And now you have to have flooding points defined for that to work. Now, let's talk more about those angles and keywords. I said we were going to spend most of our time about this. So you can specify three separate angles, and those are actual locations. And then there are, you notice that between each of those keywords, there were separator values. That C1, or that angle 1, or C1, C2, C3. So these are the specific keywords that can go in those places. At, from, to, or, between, and. And these keywords have meanings. And this is where you really need to read the help file very carefully, is about these keywords here. Because their meanings and their usage changes depending on the application. So the information that you see on your screen, this is just generic information. So when you say the keyword at, that's a specific angle, whereas from and to, those are the start and end of an angle range. When you're using the keyword or, what you're telling GHS is find the more conservative of two angles. The keyword between is only used for writing arm ratios, and the keyword and is used for writing arm ratios only as well. So those two are also paired angles. Right, let's talk about angle types. First off, you have to know that you're specifying the angle in degrees. So when you type 30, it's 30 degrees. And now let's talk about those. It doesn't always have to be an actual number when you type in that angle. And this is the other part that makes the writing arms so powerful, or the limit commands so powerful, excuse me. This is the part that makes the limit commands so powerful, is the angle specification can be a number or a keyword that represents important points on the writing arm curve. So the max 0, that's going to be the angle of maximum writing arm. You can also just type max in there, and that works. Flood, FLD, that's going to be the angle of down flooding. DI is going to be the angle of the deck edge immersion. Now, by deck edge, what they actually mean is the angle of the margin line immersion. And you can even specify that as a percentage of distance. So if it was, say, 5 degrees was the point at which the margin line would submerge, if you typed 50% DI, then it would actually give that as the angle of 2.5 degrees. So that's how that works. Now you can also type DI0, which is the actual deck edge immersion, ignoring the margin line. Equal is the angle of equilibrium. That's an RA0 here. So this one always trips people up. This is RA0, not RAO, RA0. and that is the angle of vanishing stability, what some people will call the second intercept. So the angle of equilibrium would be called the first intercept. Angle of vanishing stability is the second intercept on your GZ curve. And then pre is something that we use for certain wind roll criteria, and that's the angle of heel before roll. And roll is another thing that we'll get into later with GHS. Okay, now let's take a quick little break to describe some of the lighter sides of this. The limits title command. Like I said before, normally you're going to describe a set of limits, several of them in a row. And you'll probably want to give a title to describe that entire limit group. The way you do that is you type limit, title, and then whatever description you want to call the limits. It can be up to 25 characters long. Do not put quotation marks around this. No quotation marks here. Otherwise, those will show up in the title. And so this would be, for example, if you said it was 46 CFR 170.173 was the regulation that required all the limits you're currently defining, you might actually type in here for limit, you would type limit title 46 CFR 170.173. And that would be a very common thing to do. Now people know what regulation is being used to construct these limits. So here's an example that I just wanted to show. You can see here in GHS, I've defined a limit here, okay, and I have defined a title up here of example limits case. And then this limit report just tells it to report out the limits, and this is the output that you'll see. So here's that first limit that got defined. Notice there's that number 1, and there is the title. So that's how the limits title works. It doesn't change any of your limits. It's just some nice organizational formatting. Okay, now what I'm going to do is talk about specific applications of limits. We're going to get into each of the individual applications. So the first one are angle limits. So the way you type that one is with the keyword limit angle, A-N-G-L-E, and here's the key thing you need to know is angle is the angle of vessel heel relative to equilibrium. So if you started over, heel it over at 5 degrees because you've got some weight on the starboard side, any angle specified is relative to that 5-degree point. Now you've got also the absolute keyword is a way that you can get around this. So you can type absolute or just ABS, abs, and that's going to be the angle relative to zero heel, the upright condition. So here's a couple examples of implementation. Limit angle from 0 to max 0 must be greater than 10. So there's our keyword, and notice here's our from keyword for our angle, then that's a number, to max 0. Now remember, no absolute keyword here, so it's from equilibrium. We're asking for the limit from equilibrium to the maximum righting arm, and that's the angle of maximum righting arm, so the angle at which the maximum righting arm occurs, and GHS knows how to find that. Now if we take another example here, we go the limit the angle from absolute 30 to DI or FLD. So what we're telling here is, first off, the abs keyword came in front of 30. So it's the angle from 30 degrees relative to 0, so 30 degrees itself, to either the smaller of these two angles, either the margin line immersion or your flooding point, whichever one comes first. And GHS will check both of them to find out which one comes first. Now here's another one, limit angle from absolute 10 to RA0 or 50% DI0. So that's a bit of fun there. Now we're saying the limit of angle from absolute 10 degrees to the smaller of these two values, either the smaller of the angle of vanishing stability, which is what RA0 is, and vanishing stability is the point where your ship's going to keel right over, or 50% of the angle to deck edge immersion. And since it's a DI0 here, it's the actual deck edge. We're ignoring the margin line. Right. Now, switching away from angles onto areas. So you'll see a lot of regulations will talk about areas, especially when we're talking about things like energy concerns, making sure there's enough stability energy in a vessel. And that's where the area comes up a lot. So an example for this would be limit area from absolute 30 to absolute 40 or flood. So notice these angle specifications and keywords here, they still work the same more or less. Only now we're measuring area and we're specifying the points here. So the area between 30 degrees absolute and 40 degrees absolute, or the down flooding angle, whichever comes first. So that's what GHS is calculating there. Now there's a special case here that you need to know about. If you type these two limit statements right after each other, it's going to be doing something very special that's completely contrary to any other time you use the limit statements like this. So if you type limit area from 0 to max at 15, and then the very next limit statement has to be limit area from 0 to max at 30, then this right here is a very special case that applies to U.S. Coast Guard's regulation 46 CFR 170.173 Part C. And what that's doing is the nice people at Creative Systems have programmed this in to replace something that was a real pain to code into GHS otherwise. And what that is actually a criteria that the Coast Guard has saying that basically if your maximum righting arm happens to fall somewhere between 15 and 30 degrees, you have to actually interpolate between these two limits to find out what your actual limit is going to be. Now that's a pain in the butt to code into GHS, which is why the people at Creative Systems have set it up that if you put these two limits in this exact formatting, it will do it. GHS will do it for you. And it's a very special case. And what it's actually going to do is it's going to say the area from 0 to maximum righting arm has to be greater than 0.07 if the maximum righting arm is 15 degrees or less. It will also have to be excuse me. The area will also have to be greater than 0.055 if the maximum righting arm occurs greater than 30 degrees. Or if you happen to be somewhere between 15 and 30 degrees, GHS will interpolate between those two limits. So that's a really special case, and it will save you a lot of coding. Okay, next one, let's talk about area ratio limits. Now, this is something when you start having wind healing moment, passenger healing moments. So we are talking about the ratio of area under the righting arm curve to area under the healing arm curve. And the general argument is going to be that the ship has sufficient dynamic stability if that ratio is greater than 1. Now, different regulations have different requirements in there for safety factors, but you can see it. The safety factor is a part for the regulations. All we're concerned about is can you code it into GHS. Well, first off, notice this is a ratio against a healing moment. So you need to have a healing moment defined already. So where would you how would you code this in? Same thing as limit ratio from 0 to RA0 must be greater than 1. And that's saying the area ratio from 0 to the point of vanishing stability has to be greater than 1. That is the ratio of, like I said, ratio of righting arm to healing arm. So we're saying if you go all the way from 0 to angle of vanishing stability, your healing arm had better have as much area under it as, or excuse me, your writing arm had better have as much area under it as your healing arm. Now here's another one, is the limit of the ratio from the equilibrium angle, so that's wherever you settled at equilibrium, to RA0 or flood. So angle from equilibrium to vanishing stability, or the downflooding angle, whichever happens first, that has to be greater than a ratio of 1.5. So there's a couple examples of that. Now, let's talk about writing arms. So that's the actual y-axis on your GZ curve. So first off, you can just type in limit RA. It's your basic limit writing arm curve. And a couple examples here. So if you type limit RA at 33 or max, and they actually type the at here to make it a little bit different. That's saying the arm at 33 degrees or maximum writing arm, whichever one is less. So we're saying the at because it's only looking at one point. It's not looking at a range. And there's a big difference here now with these two keywords. So notice, look at this. That's at 33 or max. So that's saying at 33 degrees or the maximum writing arm, whichever is greater. Now, if we flip it around and say limit RA at max to 33, that is the writing arm at the maximum writing arm up to an angle of 30 degrees. And then if you didn't find it at the past an angle, if the maximum writing arm occurs at an angle past 33 degrees, you just take the arm at 33 degrees. So pay careful attention to the formatting on these two. They look very similar, but switching a few keywords around changes how GHS behaves. And we'll finish this off with a simple application as well, is limit writing arm at equal has to be greater than 0.5. Well, guess what? That limit will never work, because the way the GZ curve works, the writing arm is always 0 at equilibrium, right? It's when you're in heel equilibrium, which means you don't have a writing arm anymore. So that was just a bit of a trick application there. Okay, hang with me, we're almost done. The GM limits are the next one, and that's going to be limit GM. And this is going to be stability based upon the slope of the writing arm curve. This is only used for equilibrium or for 0 heel angles. So there's only 2 locations you can do it at. The first is limit GM at equal. So whatever your GM value is at your equilibrium angle. Now, remember, GM is not the same as your writing arm. GM is actually a non-zero value at equilibrium. Or you can type limit GM upright. And that's because a lot of these regulations were based upon when you just had hydrostatics for the upright condition. So you can do that, and that's going to be the GM value at 0 heel angle. So just to put that in perspective again, here's your GM. You can see it on the writing arm curve. And to show you a few more things, this is your point of maximum writing arm right there. And you can see here how it's going all the way back, and GHS is actually calculating that GM value, which is actually the slope of your writing arm curve right down there. And you can see how we're going all the way to 0, so that's actually the limit GM upright. Okay, let's practice this. Honestly, you can't practice limits enough. What I would really say is if you want to really practice limits, just go through all sorts of the examples that I've shown here of all the different keywords and practice typing them in. See which ways GHS will actually throw you an error. But for a little bit more focused of an exercise, we've got homework number 511. What I would like you to do is create GHS limits for the following stability criteria and add a title to that limit set. Now, these are nonsensical limits. I've put them together mostly as an exercise of your ability to program in GHS, so they don't represent actual regulations. So the first one is an area limit. So this is that special case I was telling you about. Is you have an area from 0 to the maximum writing arm must be greater than 0.07 if the maximum writing arm is 15 degrees or less. And the area from 0 to maximum writing arm must be greater than 0.055 if the maximum writing arm is 30 degrees or more. And the unwritten thing here is, and you need to interpolate between those two values. Go back to the part on the area arms, or the area limits, because I told you that this is a very special case that GHS handles pretty nicely. Now, some angle limits. Angle limits are your bread and butter. Almost anything can be defined as an angle limit. So I would like you to specify a limit that the angle of the maximum writing arm has to be greater than 30 degrees. Now that's 30 degrees absolute. And then also the angle from the equilibrium to 80% of the margin line immersion location, or your flooding angle, whichever happens first, that has to be greater than 0. So what we're doing here is we're saying that from equilibrium point to these two key locations, what we're really saying here is that at the equilibrium point, you can't be 80% of the way to margin line being submerged, and you can't have any of your flood points underwater. Because if both of these are not happening right now, then it will be an angle of greater than 0 from equilibrium to these 2 points. Last thing to specify is the GM value. Is the GM at 0 degrees must be greater than 0.5. So have fun with those. As always, the homework solutions are also provided. Okay, well, thank you very much for watching. I hope you found it informative. You can find more videos like this and the homework files and solutions to the homework files on dmsonline.us. Thanks very much.
Thanks for watching. I hope you liked it. Hey, did you know that there is a magic button down below? Click the like button or even the subscribe button and I will make more videos for you.